Buongiorno a tutti. Welcome everybody to the third lesson of this course, three-dimensional digitization. As usual, also today we have Carlos Bayod, and today we will dig into color as well, not just surface but also shape and color. As somebody of you noticed last time, we faced some problem in the streaming on YouTube, but soon we will share the complete version of every video with everybody, and also for the previous lessons, this will be there will be possible to see them completely on our YouTube channel, on the channel of Fondazione Giorgio Cini. I would like just to remember that the lessons of 10 and 17 of November have been cancelled, but anyway, the topics that we will we wanted to talk about have been will be discussed in this and the other two lessons. So the new dates are, well, today's date, 27th, tomorrow, 28th of October, and November 2 and 4. Anyway, the topics will be covered. Well, I would like to leave the floor to Carlos. As usual, if you have any questions, please write in the chat, both on Zoom and on YouTube, or ask to speak. We'll try also on YouTube, we'll try to read the questions and ask to the teacher, well, your doubts, more or less indirect. So thank you everybody for being here. Good morning, Carlos, again. And please.
Thank you, Constanza. Can you hear me well?
Yes.
Well, thank you for the introduction and for organizing these sessions. As you said, I would encourage everyone to send their questions, and there's no need to wait for the end of the talk. If Constanza can read some of your questions, I'm happy to be interrupted and answer them as we go along, because we will be covering many different topics today, many subjects, and it will be good also to be able to answer, you know, as we discuss the different areas. Thank you everyone for joining us today. This is the third session of the three-dimensional course. I would like to share my screen now. Let me see if it works. Can you see it?
Yes.
So this is the third session of this course on three-dimensional digitization, and we're going to be talking about recording and reproducing surface and shape. So in the last two sessions, we've been focused on recording surface, recording what we could refer to as 2.5 dimensions. This is a funny concept, which is something that could be referred to anything that is flat in shape, but it has texture and interest in the relief. And we were discussing how we were using the Lucida 3D scanner in the Factum Foundation for capturing the relief of paintings. And we were talking about how and why this was important to focus on the relief of paintings. And we were also looking at the practical side of it. What is really the type of files that this scanner was generating and how they can be used in a more, let's say, scientific context. What is the information that can be extracted out of that? But today I want to jump into let's say to a third dimension. We will be talking about what are the methods and systems that we use in the Factum Foundation for recording not only the surface of things, but also the volumetric aspect of objects. We will be talking about how we use digital technology for recording sculptures, architectural elements, facades, buildings, even urban areas. And all the different projects that I will be discussing today have to do with this idea of applying digital technology for recording cultural heritage. I want to be talking about how we do it in Factum, because in almost 20 years of experience, we have been developing certain expertise and in how we approach this idea of applying digital technology for recording cultural heritage. Most of our projects, or I would say all of our projects, are they have in common these three aspects. We are talking about digital way of capturing information. We are always focusing on non-contact recording, so we are never manipulating or touching the original work of art or the original site. And we are focused and committed to high resolution. But I want to stop here for a moment, because high resolution can mean different things to different people. This is an example. What you have on a screen is a section of a relief from a facade of a basilica. I will show you exactly where this is taken from. And this object has been digitized with two different systems and then reproduced physically also with two different systems. Each of these scanners could be considered high-resolution scanners, but we are very much focused on understanding the importance of resolution as the density of points, because this is what is giving us the amount of information that defines what makes an object unique. This is different in a way to accuracy. So if you consider resolution as the amount or the density of points in a space that can define a surface, accuracy could be more related to the precise location of those points in space. So when you are defining, when you want to apply 3D scanners, for example, for industrial applications, you want to apply it for metrics to really evaluate the dimensional aspect of something, you are interested in accuracy. But when it's about cultural heritage, it's mostly about the amount of points of information that can help us define what is unique about that object. And this is why over the years, we have become more familiar with this idea of how correspondent to reality is the digital data we are capturing. So this concept of correspondence to reality is essential for being able to capture information that could be useful for the preservation of a particular object. Again, this is another example. This is the reproduction of a section of a brick wall that was recorded with two different systems. And one of them is clearly, the one at the top, is showing more faithfully, or it's more true to the real texture, to the real character that it's actually defining that precise brick in that precise part of the wall. It's not just one standard brick, it's not just the general shape of something, is that accurate part of the wall that we would be interested on. And this is why for us, and we believe that for cultural heritage documentation in general, resolution, high resolution, it's all about how correspondent it is, a digital data, to the real surface of the object. And this is especially important because the way we are understanding digital preservation is not only by archiving certain digital information that could be essential for the future. It is also about how you rematerialize this information back into a physical environment. it is this two-way trip between the digital and the material that we are interested on. And in a way, most of the projects that we do, and certainly those that I will be discussing with you today, it's all about how you transform the digital information back into a physical material reconstruction. Normally, each project is different. Each project needs its own research and its own way of understanding the methodologies and the systems that are available for it. But mostly, there are 4 steps, at least, that are necessary in the process of making a facsimile for preservation. So once you have recorded, I mean, this phase of input, once you have recorded the digital data from an original artifact, you have to process that information. And then you have to find a way to bring that 3D model or that final model or any other final file that you are generating after processing back into a physical form through prototyping. This could be, just as an example, for example, 3D printing. And then the last step is all that you can do to that prototype in order to make it look exactly like the original object. And this is where the craft skills and the different craft techniques are necessary, because at the end, most of the work we are doing is always this combination between digital data and craft skills that will make a facsimile really something useful and essential for the purpose, which is at the end helping the preservation of the original. So talking specifically about 3D and 3D capturing and 3D reproduction of information, we would like to differentiate first between 2 types of approaches. One of them is the long-range scanning, another one is close-range scanning. There is no very strict differentiation between both of them, but it's mostly about the application you are trying to use out of each of these groups of systems. For example, we can talk about long-range scanning when we use a LiDAR scanner, this system that is normally employed for capturing the facade of a building or a big area in a city, something that is really for large scale. And certainly the scanner works as something that works from a certain distance, from various tens or even hundreds of meters. So a LiDAR scanning, which is something that we would consider as a support system, not specifically for capturing high resolution the way we consider it, but mostly as something that provides like a general framework of accurate data, because the main characteristic of this type of scanner is that it is locating points in space in a very accurate way. We normally use this in combination with other close-range 3D scanning systems. A very quick example of this, of how this system is used, is when we were asked to record the sculptures and the reliefs of the 3 main gates of the Basilica of San Petronio in Bologna. We were focused on using close-range 3D scanning systems for capturing every detail of the sculptures. But at the same time, in parallel, we used a LiDAR scanner, specifically a Faro scanner, in order to document the facade in a very accurate way. This is a diagram of where the scanner was positioned, because at the end it's about placing that scanner on top of the tripod in different locations so that you could obtain a complete cloud point, so a complete system of points located with X, Y, Z coordinates in space. And this is the type of information you can obtain. It's about how you are recreating in a virtual environment, in this case, an urban space like the square and the facade of the basilica and the other buildings around it. This system works by measuring the time it takes for a laser signal to hit, let's say, the surface of the object you want to record, and receive that signal to the sensor in the scanner. So the closer you are to the object, the higher the density of points you are actually measuring. The resolution that we are getting is not enough as to understand the specific qualities and details of the skin of things, but it's enough as to provide, as I was saying, a framework of accurate position of points in space. For this project in particular, that we were carrying out back in 2013, we were using a white light scanner, also called a structured light scanner, to focus on the detail of the different sculptures so that we could create a proper record of not just the general shape of each object, but also the specific qualities of the skin, of the surface of the stone that would make this object unique in relation to others. We were doing this work and we were working on this project in collaboration with the Basilica of San Petronio, and also we were recording just before the Opificio delle Pietre Dure were doing their own cleaning and conservation project. So it was one very effective way of working by the fact that we were actually applying high-resolution digital recording to objects that were about to change. And this is why it is essential to be able to obtain proper high-resolution information of things that are going to be experiencing changes on the surface. These are two of the systems of white light scanning that we have been using over time. The first of them, a CDO scanner, is operating by projecting a pattern of linear light on top of the surface you want to record, and then with one camera, the distortions of those lines are being captured and then converted into 3D information. The Breukman scanner is working with the same principle, but using two cameras. So when we want to record an object like this, it's all about projecting this series of parallel lines that in contact with the sculpture, they are distorting, so the cameras can interpret that distortions as actual 3D information, and then locating these points in space. It is a very precise system. It has very high resolution, even higher resolution than 100 microns. And it was very useful to understanding what was the current conservation state of these sculptures, which contain, for example, artworks from Amico Aspertini or Jacopo della Quercia. I want to show you this video so you can see very quickly how the system works. This is, of course, accelerated in time. I hope you can see it. I am seeing it now on my screen.
Not yet. We see just the link.
Okay, so can you see it now?
Yes.
So this is a video that shows the process of recording this series of reliefs on the walls of the Basilica of San Petronio with a white light scanner. The green light that is also appearing, it's like an additional aid system, something that could help us to know what areas have already been captured, so that the operator of the scanner, as you are covering the shape from different angles and different points of view in order to cover the full surface with some overlap. Thanks to these additional green projections, you are capable of understanding what areas you have already captured and which areas are still to be recorded. At the end, the system is capable of taking all these individual shots and combine them automatically by finding points in common in order to create a full 3D model of the area. This is a screenshot of what happens when you start to process the information captured with a white light scanner. Each color is actually representing one different shot, one different individual scan, and then the software that processes the information is actually aligning all these shots together in space, so that at the end what you obtain is a continuous surface. You can see that there are gaps. There are areas that, because of occlusions or just points that were too deep for the scanner to capture, they are showing no data. You can actually see the background in between the actual 3D model generated here. And this is normal, but this is something that it is always possible to fill. You can fill the gaps in order to create a continuous and coherent and complete 3D model, taking always into account that because we are managing cultural heritage information, it is very important to always keep a difference between what is original capture data and what has been filled as part of the processing. This is essential in case we want to go back to this data in 10 or 20 years' time, and it should be necessary to be able to differentiate what was captured by the scanner and what was added as part of the processing. But as you can see in an image like this, we are capable of looking at every detail on the surface of the sculpture, not just a general shape. We understand photogrammetry also as a close-range scanning system because we have been specializing in using photogrammetry to capture also the minute detail of the surface of things. We have been evolving in the way we have been learning ourselves how to improve our photogrammetric data, how to make it something really useful for understanding relief and surface information. And this is why we really are, in a way, considering photogrammetry as the main tool that we have today for recording cultural heritage in Factum Foundation. When we have to record the surface of a painting, we still have the Lucida scanner as the main system, because there are certain elements related to varnish, related to darkness, or even the absence of specific features that for photogrammetry are complex, are complicated to capture. But for example, the project I was just showing you about recording the sculptures on top of the facade as part of this conservation project, that we were doing it with a white light 3D scanner. Probably today we would have done this project with photogrammetry because of the facility. It's much easier to use, it's faster in a way, it does not depend on having a perfectly stable with a space without vibrations, etc. It's more useful for field recording, for field work projects. And this is why, as we advance in being able to capture better data and higher resolution data, we are more and more using this methodology for new projects. All you need at the end is a camera and a proper methodology. And you should know how to define a strategy for recording an object. As you know, photogrammetry is about taking multiple photos from different points of view, from different distances, with some overlap between them, in order to generate a 3D model out of this information. So the process can be planned in advance, should be planned in advance. A strategy should be defined in order to make sure that you are approaching the object from capturing the general shape and then focusing on specific details. But the way it works is about making sure that the light is correct, that the distance and the strategy and the type of pictures you are taking is correct. And what you obtain is a series of images. For example, this small sculpture of a virgin, you have the object photographed from different points of view. And then with software such as reality capture, for example, that's the main one we are using, it is possible to compose a 3D model that contains at the same time the shape, the surface detail, and the color on top of it. The color is something that could be, in a way, hiding the real resolution of your 3D model. And the way we really want to show the quality and the resolution, the amount of points of our 3D models, is to show the information without the color as well. Because when you are looking at something like this, it is easy to think that the color texture is equal to 3D resolution, whereas what we are looking for is exactly something that contains the highest possible density of points for the specific object we are recording. Photogrammetry is also an ideal technique when you need to record in remote sites of difficult access. And this is why we have been using this method for a series of projects in East Africa and the Middle East that tomorrow my colleague Otto will be explaining how this type of projects have been planned and what is the application of photogrammetry specifically for this type of projects. But today, I want to focus on what is an ideal way of combining all these different methods together. It is usual that in the Factum Foundation, we are always combining different types of scannings, from close-range 3D scanners to long-range 3D scanners in one single project. Normally, when we are recording a painting, it's all about capturing 3D on one hand and color on the other hand. But leaving the color recording aside for today and focusing only on 3D recording, I want to show 3 projects in which we have been applying a combination of different 3D scanning systems for capturing information, and then how we have been applying different prototyping methods for bringing these 3D models back into a physical realm, into a material world. And I want to do it through 3 projects that are actually related together because they have been focused on 3 different tombs: a tomb for a king, a tomb for an artist, and a tomb for a cardinal. The first one of them, the tomb for Seti I in the Valley of the Kings in Luxor, it is a project that actually has been part of Factum from the very beginning, since the year 2001, as I was showing you on the first session. Working in the tomb of Seti I has helped us to develop new technologies and apply them in innovative ways, because we always have the task of how to record with the highest possible quality and the highest possible resolution hundreds of square meters of painted reliefs in the tomb of Seti I. We understand this project as a true preservation project because its main goal, it's about protecting the original monument and protecting the original archaeological site from decay, and to be able to create a proper archive of information that could be useful for the future, for future generations. The tomb of Seti I, it's probably one of the most interesting in the Valley of the Kings. It's one of the most famous archaeological sites in the world, and it has been studied a lot in history. It has been admired, and precisely because of this admiration and because of this amount of research and attention that has been put onto it, it is also in a fragile state of conservation, which is visible on the surface of the walls. Many areas have already lost their original relief because of different ways of reproduction and copying that have been happening in the past. Also, even because of specific ways of restoration or attempts of restoring parts of the wall. And this is why its conservation state is not great. And for many decades, the access to the tomb has been closed to visitors precisely in order to help its preservation for longer. Since the year 2016, the Factum Foundation has been carrying out a project precisely focused on applying high-resolution digital techniques to record the relief and color of the complete area of relief walls in this specific site. And we are at the end of 2021, and we are almost completing this project that, as I say, the last phase started in 2016. And this has been possible thanks to working with a very special team of local operators, because part of this project was about making possible a transfer of skills and a transfer of knowledge from our expertise in Factum to the people in the Valley of the Kings, the people in the West Bank, in Luxor. It is them who have been in collaboration with our own technicians in Factum Arte, who have been making this initiative possible. They have been using different Lucida 3D scanners to record the walls. They have been learning how to process the information, and they have been, in a way, making this project as something that should, in a way, reinvest in the welfare, or in the best, in a better quality of life for the area in general. So this is an area in Egypt in which tourism is important. Preservation of the monuments that are attracting tourism is also very important, and then preserving them also in digital form is the way we understand we can help this project to actually have continuity in the future. You already know how the Lucida scanner works. I was showing many examples in the previous sessions, but if you remember, it was about how to apply laser scanning, laser triangulation scanning into objects that are mostly flat in terms of shape, like a wall relief, but with the capacity of really capturing every single detail on the surface that could be essential for understanding its conservation state. These are some renders, like simulations of the relief, that are making possible to understand the texture that is being captured with the 3D scanner as an image point of view. So the main system we were using for recording the walls in SETI I is the Lucida scanner, and this is valid for the main part of the walls. But then, what happens with the corners? What happens with the ceilings in the different corridors, in the different rooms that form the complex and labyrinthic system that is the tomb of SETI I? In order to access these complicated areas of the space, we are using photogrammetry. And thanks to that, it has been possible to capture the complete parts of the different rooms, especially those areas with difficult access, in order to complete what we have recorded with the Lucida scanner. So here you have already two systems becoming complementary, one with the other. You have something that we know that it has a 100 microns resolution, so that's the resolution of the Lucida scanner. And then with the photogrammetry, we can try to get close to that resolution in order to complete the areas of the walls that are not being possible to obtain with the Lucida. These are images, like screen captures, of the first attempts to align the information captured with photogrammetry. And at the end, it's about how to understand what are the limitations of each technology, and where one has a limitation, then maybe the other type of recording technology can continue and can complete the work. For the color of the reliefs, for the color of the painted reliefs, we were using panoramic composite photography. In this case, the way this works is different to photogrammetry, because it's not about taking pictures from different points of view and moving the camera, let's say, in parallel to the wall. With panoramic photography, it's about placing the camera in the center of the room at a certain distance to the wall you want to record, and then carry out composite photography as if you were recording in mosaic of rows and columns. And then with these different individual shots, you can compose one single image file in high resolution. This is only for capturing color. And this is what we were using not only for the color of the walls, but also for the ceilings, which contain a great deal of the information that is important in this site. You can see in this image a screenshot of the process of aligning these individual shots of the panoramic photography, so that the perspective is also being corrected. It's also being compensated or balanced as part of the processing in stitching all the different images. A fourth system we were using, also for recording the space in the tomb, is a LiDAR scanner. In this case, also a Faro scanner. And thanks to this system, it was possible to capture the general space structure of the tomb. And this creates a series of points in space, also with the color, because this LiDAR system can also record color, although we mostly use it for reference. We are never considering this color accurate enough as to be able to represent accurately the proper color qualities of the space. But this type of visualizations allow us to understand the spatial configuration of the tomb. This is a rather interesting view, because we recorded the space, of course, from the inside. We were placing the Faro scanner in different positions throughout the space, in the different corridors, in the different rooms. And then the scanner is creating this point cloud, in which each point is represented by an XYZ coordinate, as well as its own color information. And then it is possible to generate these external views, as if we were looking at the skin of the walls from the outside. And this offers a very interesting point of view of any space, because it's allowing you to see it in a way that it's not possible to do it when you are inside. The recording of the space with the LiDAR, it's something that is useful to obtain an accurate location of the points and the planes in space. It's not giving enough resolution, at least from what we need, to define the qualities of texture of the walls, but it can give us a proper set of measurements and dimensions onto which we can then map the other types of data that we were capturing with the close range systems, with the Lucida or with close range photogrammetry. And this is what we were using. Once we are recording all these different types of data, and we are back in our workshops in Madrid, we have to be able to combine the different information, the different types of resolution and the different formats, in order to produce a facsimile of the different rooms in real size, because that's at the end one of the goals of this project, not only to create a proper archive of the current conservation state of the tomb, but also to create a physical replica, create a preservation facsimile that could be eventually in the future be installed in the Valley of the Kings near the original tomb, so that it will be given the possibility of visiting the facsimile to the visitor, so that there is always a way of visiting the monument, but at the same time helping the preservation of the original monument. We created a first version of this facsimile of a few of the main rooms in the tomb for a temporary exhibition in Basel, in Switzerland, in the Antiques Museum back in 2017. But at the same time, we kept recording, and we had a permanent team in Luxor recording the other rooms, recording the entire tomb, so that eventually, as I say, it would be possible to build this reproduction, this facsimile, in the Valley of the Kings in Egypt, because that's the original goal of the project. I want to show another video that goes after this one. Can you see it? I hope so.
Yes, perfectly.
So this is a short video which is showing more or less how is the data put together once we are dealing with preparing the information for a physical reproduction. The different sets of data, remember we are talking about hundreds of square meters that were captured with different scanning systems, 3D scanning systems and color recording methodologies. We were looking for ways of combining this information, which requires most of the time to apply different software that was not primarily defined or designed for this type of applications. But for example, we were experimenting with software for topographical projects, software that is about how you handle with aerial information from a terrain. And thanks to this type of lateral thinking, we were capable of combining the data from a laser scanner with photogrammetry, also with the LiDAR recording systems, and then create continuous surface, each with its own different resolution, but being able to create something we could reproduce physically with different means. These different mediations are necessary because when we are fabricating something, for example, like in this video with a CNC milling machine, in a way, for us, it's like a test that the data that we captured was obtained in the highest possible resolution. Because on screen, many things can look nice, they can look interesting when you look at them in a virtual environment, but it's when you are trying to bring them back into a physical thing, into a physical surface, when you can really test that the data that you obtained was right or was wrong. For creating the facsimile of the tomb of Seti I, most of the wall reliefs were recreated with CNC milling machines, like this one on the video now. This is a 3-axis routing machine, and we were using high-density polyurethane resin panels, which is something that is relatively soft for the routing machine to carve, in order to be able to reproduce the relief in with the highest possible resolution. As you can see, there's always 2 steps in the process of recreating this texture. It's about removing the extra material that you don't want. So the machine usually does it in 2 steps. First one, a rough cut in order to have a general shape and this is why you can see these lines of the passes of the bit of the specific tool that was milling the material. And then a second step with the fine cut, that is the one that actually is capable of reproducing the precise detail that we capture with the scan.
Carlos, sorry if I interrupt. It's
Sure.
just a curiosity. Is the CNC milling machine in-house in Factum or not?
Yes, this is one of the machines. We have various units of them, and actually we have them working almost 24 hours. They are always constantly in operation, because this is one of the primary ways of reproducing any 3D information that we have. We also have other types of machines, 3D printers in-house, which are actually small size printers for small prototypes, tests of materials. But mostly when we want to 3D print big objects, we outsource this service to other companies. But for the milling, for using the numeric control milling, we have the machines in-house.
Great. Thank you.
And they are making this noise all the time. So this is why it was important to show you with the sound.
Thank you.
Here you can see this the difference between these two phases of routing I was mentioning. First for general shape, and then for the actual reproduction of relief. Once we have recreated these reliefs on the resin panels, it is possible to proceed as if it was a traditional sculpture technique. You can do a silicone mold, and you can extract the negative of the shape and eventually apply it to cast another positive in case we wanted to do a second copy or a third copy. So the routed resin panel, it's in a way the first positive or the first prototype, after which it is possible to make other units if it was necessary. It's an image of the negative relief of the actual silicone mold. And then the way we apply the color onto this relief, it's something also that we had to develop over time, over experimenting with different projects. And it consists of printing the color onto a very thin, very flexible skin, capable of receiving the color print with good quality. And then we could apply, as you will see in a minute, we could apply this skin manually on top of the relief. So it is working in two steps, actually the same way that we were capturing the information using 3D scanner on one hand and color recording on the other. For the physical reproduction of this information, it's also about doing it in two steps, relief on one hand and color on the other hand. What we do is we take the 3D information captured with the Lucida, for example, or with photogrammetry as the base on which we register the color on top. So we consider the 3D information as our dimensionally accurate reference, because we understand that the color can contain some distortions because of the lenses, because of the different ways photography was captured. So we digitally apply this process of registration, distorting the color slightly on top of the relief information, so that each detail in the color corresponds to its corresponding detail in the relief. So this is a manual process. This is, of course, something that it's necessary if we want to recreate something physically that restitutes the original work. The color that we have in our digital files and the relief that we have in our digital files, it has a precise correspondence to the original. The way we are combining, in this case, the skin with the relief manually, thanks to a very dedicated manual work, of course, it has its limitations in terms of how accurate you are being. But in a way, this is part of our understanding of facsimiles as a byproduct of the important thing, which is having the data. So the relevant aspect of a project like this one, which is about the recording of a monumental work of art, like is the tomb of Seti I, is about the digital files that you can keep for the future. The ways of making this as a physical facsimile depends on the current techniques that we have at this very moment. Maybe in the future it will be possible to make reproductions in a different way, but they represent the current state of techniques. But as I'm trying to say, the important and the essential thing is that we have the actual files of the different 3D scannings and the different color recordings that we carried of the tool. After registering the skin manually and applying glue in order to fix it to the relief, thanks to a vacuum machine, the two layers of information remain fixed as a solid object. Moment. We had to follow this method for the different walls that we wanted to recreate. We are talking about that for this specific exhibition that we wanted to do, it was about recreating one of the most beautiful rooms in the tomb of Seti I, which is called the Hall of Beauties. And we were also looking at the next room, which contains a series of pillars that is also very characteristic of the space of Seti I. We are, of course, reproducing it exactly as we recorded it. So the main goal of this facsimile was to show the state of conservation of the tomb when we were recording it from 2016. But we were also looking at how to apply these technologies in order to show other versions of these wall reliefs. The exhibition that we were doing, that we produced for the Antiken Museum in Basel, was about the historic trajectory of the tomb of Seti I in the last 200 years since it was discovered by Belzoni. So it was about talking how things change, how this type of elements are actually dynamic objects that are always changing their material nature, precisely because of the act of care and attempts of preservation and attention that has been put onto them. We can now record these objects with non-contact recording, but at the time of Belzoni and other archaeological campaigns, every time you wanted to take a mold out of a relief, you were actually applying a direct mold on top of it, and in a way you are, even if you didn't want to, you are contributing to their decay through this act of interest and through this act of admiration for the work of art. And this was, in a way, the irony and what we wanted to explain in this exhibition, that no matter how you try, no matter how you want to help preserve something, every time you act onto an original, you are modifying it in a way or the other. For this facsimile, we were also showing the tomb in a way that was even more complete than the original. So we were also looking at what are the fragments of the different parts of the walls that can be found in different museums. For example, in the Boston Museum of Fine Arts, they have small fragments from the tomb of Seti I. So we were carrying out also a recording of them in order to be reintegrated in the general facsimile that we were doing. So this is part also of a research project that has a lot of implications. You are capable of showing not just the tomb as it is in Luxor, in the Valley of the Kings, but you are also showing what are the other fragments of the monument that are now in different locations in the world. This is a section that is in Paris, in the Louvre Museum. This is another section that is in Archaeological Museum in Florence. And one of the main elements that originally belonged to the tomb of Seti I, which is now in a different location, it's the sarcophagus of Seti I. This is extraordinary piece. Is made out of one block of alabaster, and it is probably the central piece of the great museum in London, the Sir John Soane's Museum. This element was recorded a few years ago with close-range photogrammetry, with the aim of having not only the general shape of the sarcophagus, but also every detail of the texture that could tell us the specific text that is written on the inside and the outside of this element. This is the resulting 3D model that was obtained with photogrammetry. And when we were looking at ways of reproducing this object, we considered very briefly to actually do a routing in the same material, in alabaster. But we decided it was going to be more accurate and more true to the actual object if we did it just with a different technique. We decided to carry out a separation, digitally speaking, to separate the shape of the sarcophagus from the actual relief of the sarcophagus. And this is something that it's possible thanks to digital transformations that that were experimented, and this allow us to do the following. We could then process with taking the skin, let's say the actual texture of the sarcophagus, as if it was a series of flat sheets of information, and then apply this technique called elevated printing. This is something we now have in-house, but at the time it was in Canon facilities in Venlo, the Netherlands. And this system basically consists of it is a kind of 3D printing. So it's an additive manufacturing technique. It consists of printing layers of ink mixed with a certain type of resin, so that it is possible to print on this type of flatbed printer color and relief at the same time. So what you are seeing now is a stack of layers of ink, which the last one, the top layer, contains also color information. So this is what we decided to do for the sarcophagus. We decided to take the skin containing color and relief, as it was captured with photogrammetry, and then have it as separate two-dimensional sheets that we could apply to the low resolution reproduction of the shape of the sarcophagus. So thanks to this elevated printing technique, we could reproduce this object like this. You can see there is like a general shape in this gray material, which was routed, similar to the machines I was showing at the beginning. That was subtractive manufacturing technique, so that you are removing the material you don't want until you get to the shape and texture you are looking for. And then on the other hand, we were applying the skin with the texture and the color, thanks to this additive manufacturing technique, which is a kind of 3D printing, and allowed us to keep the highest possible resolution in the reliefs. In order to make this, it was necessary also to take into account the distortions that are going to be applied onto these flat sheets of material when they were going to be in contact with the volume, with the volumetric shape of the sarcophagus. And this type of distortions could be anticipated up to a point, applying some distortions in the files before the elevated printing I was showing. There is always this combination of digital mediation and craft skills. And it would be not possible to create an object like this if it is not because of this combination of digital and manual techniques. At this moment, there is no system that can 3D print with color, with enough quality, in order to make something a meaningful facsimile. We have to use the combination of different systems, and we have to innovate and invent new ways of approach the different available technologies if we want to recreate something like this. And of course, a certain amount of manual retouch is necessary to fix the joints together, similar to the gap filling I was showing at the beginning. The essential thing is that on a digital form, we have a proper record of how this object is looking nowadays. For the facsimile, it is okay to actually fix these joints, fix these elements, because this is something that is showing the information we have digitally, but it's not the end of the work. I mean, the real importance of this type of work is to actually have the information properly archived and properly saved. These are some images of the result of this work of making a facsimile of the tomb of Seti I. So this is real size, 1:1 scale. This is the Hall of Beauties. So as you can see at the end, it combines the information of the walls and also the ceiling And this is thanks to the combination of the different 3D scanning methods, the Lucida scanner, photogrammetry, the LiDAR recording, and color. This is the other wall. You can see all the areas that are missing the wall reliefs. And this is, as I was saying earlier, because of different factors. At the end, it's because of the way this thing decay when you are actually opening them to visitors, when you are opening them to researchers. In a way, you are, even if you don't want it, you are changing them forever. And this is why it is essential to be able to record them before further damage or before further change is happening. This is another section of the facsimile, the pillared room. You can see that except for the floor that needed to meet all the different safety regulations for visitors, etc. The rest of the walls, the rest of the space, the ceiling, etc., is the result of materializing the different data that we captured with the scanners in the original site. The exhibition was also about the different ways in which technology can help us understand an important site like this. So there were other methods of showing information. At the end, all intended to allow a more natural and more complex relation with the object, and creating maybe even a more rich experience, a more authentic experience than if you were visiting the original in Egypt. This is an image of the version of the Hall of Beauties that is showing not the actual condition of the tomb, but a hypothesis of reconstruction of original colors that we tried to recreate based on the actual documentation created by Belzoni, based on the watercolors created by Belzoni, who discovered the tomb 200 years ago, and then offering, opening a window to, time travel. If you wanted to travel to that Hall of Beauties the way it used to be a couple hundred years ago. All the different fragments that were recorded from the museums, they were also on display. And thanks to this, it was possible to appreciate the different levels of restoration that have been applied onto the objects. So that if you visit each object separately in each museum, you don't really understand how much each object has changed until you see them all together. And then you can understand what is the restoration policy that has been applied over history in each of the museums. So that an object that must have looked similar originally, over time, it has taken its own look. It is looking its own way because of human intervention. And this is what normally you don't get when you are just visiting the original object in a museum. So this fragment here on the right, it's supposed to be a twin panel, one in front of the other. And this one is in Florence. So you can really see how different they look now, just because the different historic trajectory each of them has been having in each museum. And the central piece of the exhibition, again, the sarcophagus of Seti I, which I think it's probably, in terms of the way it was fabricated, one of the most sophisticated ways of making a facsimile of something, because of this combination of subtractive fabrication technology and additive fabrication technology. If we have decided to make this object routed in alabaster, the material would be the same as the original, but it is never possible to achieve exactly the same tone of the stone exactly the same way that the color is fading in the different areas, so that it was decided to go for completely different materials, in this case, a core or a body of resin covered with this skin of ink, so that when you touch it, it really does not feel like stone. It is not like alabaster, but on a visual level, it's a perfect restitution, because you should be able to inspect this object exactly with the same level of complexity as if you were inspecting the original object. And this is the goal of a work like this, to be able to facilitate new approaches and a new understanding of an original site through digital technologies of recording and reproduction. You have any questions or comments?
I have a question, if it's possible now. Regarding the recording of color, in some situation, probably it's easier to control the ambient light and natural light, and in some other situation is probably not so easy. How did you manage this aspect?
So generally for recording color, we use always our own lighting systems. So we need to be in control of the light through using flash. And that's your question, no? At the end, we are not relying on the light in the place, the ambience light. We have to be in control of that. So
sure, yeah, I was thinking maybe in a place with a lot of light or other sources of light, it has been difficult, or maybe not.
So maybe sometimes for photogrammetric recording, which is also about taking pictures, you can use the light that it's already the ambience light on site, if there's enough light. But when it's about recording color with the intention of being very accurate in the color that you are capturing, like for example, for recording a painting, or in the case of the wall reliefs, it's always better to use our own lighting system. And especially because we want to avoid the appearance of any reflections or any shadows in the image. So this is why we normally use, probably I explained it in the previous session, but we use a double lighting system when we want to record the surface of a painting or a wall relief, so that we take the same image with light from the left and then with light from the right, so that in the processing phase we can combine these two images and take the best out of each. So we can we can substitute an area with a shadow or an area with a reflection with the proper data from the other picture. As a result, we obtain something that is very accurate in the color and perfectly flat, in the sense that we have no additional information about the relief, because the relief is something we obtain with a different system, with the 3D scanner.
Thank you.
I want to show you another project, which is a very different approach, and you will see why in a minute. And I want to start by showing what was the recording of this particular original artifact. Can you see the video?
Yes, yes.
The one on the floor, not so much because
So this is the tomb of Raphael in the Pantheon in Rome. We had the commission of creating a reproduction of this tomb, of this monumental tomb, and again we were using different systems in combination. You can already see some of the, you can be familiar with some of these methods. We were using a LiDAR scanner to record the actual internal space of the Pantheon, obtaining information like this, which is very accurate in the metrics and position of points, although not providing enough texture quality. We were also using photogrammetry, handheld photogrammetry with the camera, to record specific architectural elements like the capitals in the columns, like certain surface elements in the tomb, certain sculptural elements as well with photogrammetry. You can see the way this is done. It's basically holding the camera with its own lighting system mounted on top, and thanks to that, after obtaining hundreds of pictures, we can get even higher resolution to what the LiDAR is offering. And then it was very important to capture the marble stones very accurately. And for that, focusing on the color, we were also using panoramic composite photography, as if we were recording a painting, but trying to get the ideal color, the perfect and true color of the marble stone. But this job at the end, it's this was for an exhibition, and this was in order to be part of a show about Raphael, which, as you know, last year, 2020, was the anniversary of Raphael's death. So the goal was to be able to recreate this section of the Pantheon. We are talking about this fragment. That's where is supposed to be buried Raphael, in order to be part of this exhibition, but at the entrance of it. And this was a very interesting approach, because the itinerary of the exhibition in Rome, in the Scuderia del Quirinale, actually started with the death of Raphael. And it was then going backwards, showing many important artworks by the artist. But this idea of starting with the tomb required to have an object that, of course, it couldn't be transported from its original location in the Pantheon. It had to be recreated as a replica. So after a few nights working in the Pantheon, when it was closed to the public, it was possible to obtain a good set of data, color information, 3D information of the space with the LiDAR scanner, also close-range photogrammetry of specific elements. And with this information, back in the workshop in Madrid, we could start the production of the facsimile for this exhibition that, as I was saying, in the title of the exhibition, it's already the dates of birth and death already with a changed order, beginning with the year of the death. So making a reproduction of this, it requires employing many different techniques. For example, for the main Madonna sculpture, you have to apply a great deal of manual work. There is no need of making a very high resolution routing. You could have, let's say, a medium resolution routing if you know that at the end the details are going to be applied carving and sculpting by hand. So this kind of light orange material that you see, it's medium density resin that was carved and routed with another type of CNC milling machine. And that would be just the first prototype that will end up looking like the image on the right, thanks to applying these tones, this imitation of the material, but mostly by hand. Other elements, actually all of the elements were a combination of some level of digital prototyping, even though not necessarily in high resolution. Every time you see this light orange material is because it's not high density resin. It's like medium density, so that it does not allow to reproduce information with very high detail. You have to keep the level of detail at a certain, with a certain compromise. So many of the elements of this were actually finished by hand, applying the color by hand, thanks to the artisans in Factum, so that this puzzle that you are composing, it's a combination of different techniques. But there are also elements that were necessary to print, or 3D print in this case, in high resolution. So for example, the capitals of the columns that were recorded with photogrammetry, these are accurate reproductions of these specific shapes and these specific volumetric decorations. At the end, the finishing is always by hand, and the applying of this kind of patina or final tone is applied as if you were applying polychromy on a sculpture. But then we were using our own flatbed printers to reproduce the color of the marbles that were captured with composite photography. And this was very important because if we were about to recreate this tomb that is so relevant in the materials that were chosen for it, we could not show inaccurate reproduction of the marble. This is why they were treated as if they were paintings, with the same attention to being accurate in the color reproduction of these elements, even though we were just printing completely flat. We were not trying to reproduce any texture here because we did not have any information. They were not recorded with the Lucida scanner, for example. So they were mostly about how to reproduce the color accurately. And this is one of the important things that I would like to mention today, that it's not about applying the highest level of resolution to all the elements that we have to record for a project. It's about trying to understand what is the hierarchy of the elements and realize what is the best technology, what is the best resolution for each particular object, depending on the scope of the project. Some weeks ago, Factum's director, Adam Lowe, was explaining the recording of the entire island of San Giorgio. And he was explaining the different techniques that were put in practice. And it was not about recording the whole island as if you were recording a small painting with that level of resolution. Some areas had to be recorded with less resolution. Some areas need more attention and more focus. And this was the same case as with this job. It's about trying to differentiate which elements are relevant to be reproduced with the highest possible quality and which others are just about creating a framework for this scenography that you are trying to put together in this exhibition. This is the way we were assembling all the parts together in our facilities in Madrid. And then the installation in Rome, in the first room as you enter the show, it required this last finishing by hand to put all the joints together to make it look not as something that was made in 21st century, but something that, even though it was out of its original context, it should feel like stone. It should look really as if you have moved the original monument from the Pantheon to a new setting. This is the view that you get as you enter the exhibition. And it was a good example about when it's important to show a replica in an exhibition that is made out of originals. And we believe it's going to be more and more important to create exhibitions that combine original objects with this type of reproductions that can create the proper context to understand the original elements. As you can see in this image, you enter the exhibition. You can see the tomb of Raphael. You can have a first reference about his sudden death as a young man, and then you start to look at his work and his life through the different paintings that were selected for the exhibition. Any question? Comment? Actually, if you remember in the last session, I mentioned this cartoon by Raphael that we recorded in the Victoria and Albert Museum in London, and we created a facsimile of it. It was precisely for this exhibition. So together with the other original artworks, there was the reproduction of the tomb of Raphael and the facsimile of this cartoon, which in this case, it was accurately representing the color and the relief exactly as it is in the original. So this idea of combining originals with facsimiles as part of temporary exhibitions, I hope it will be more and more common in the future. Finally,
there is sorry. There is a question from Maria. She asks if she remembers right, the Raphael tomb was reproduced slightly smaller than the original, but I'm not sure if you said this or.
That is correct.
It's correct.
It was reproduced, I think, maybe 90% of the original size, or 95%, almost the original size, but slightly reduced. So it could
space
fit
problems or
exactly. So it could fit in the space in the Scuderia del Quirinale for the height mainly. After this show, it has been taken to Urbino, and this is now on permanent show in the city of Urbino. And but yes, Maria is right. It was slightly reduced in size.
And I have a curiosity. So these images are the installation view of the exhibition, I guess. And was it mentioned at the entrance that people were seeing at first his tomb and the facsimiles of the tomb? Was it explained or not?
Yes, those things are always explained in the label of the artwork. It's explained it's a facsimile made in 2020 with this and that technology, and it's not about trying to hide the fact that it's a copy. It's about actually attracting the attention about the fact that these things are possible to be done. And for something like this, that it's not possible to be moved, thanks to this technology, you can actually make it part of an exhibition. It's the same as with the cartoon. So you can look at it and admire it from a distance. You can get close to it. You could even touch it. because it's a reproduction, it's not the original. So this allows a more natural relation with the object, thanks to the fact that it is not an original. That first, it should not, maybe it could not travel from London, but also if it traveled, it should be protected behind a thick glass. You should keep a distance. Lighting should be of a certain way. So having a more natural contact with the works of art, it's one of the great advantages of facsimiles, and the label always says it's a reproduction.
Thank you. Yes, in fact, if I remember well, if you see the cartoons of Victorian Albert, they have a slight greenish gray color due to the lighting and the glass, and so it's exactly as.
No, it's you are right. It's very impressive to see the Raphael court in the V&A Museum. You can see the 7 cartoons, and it's very monumental space. But you don't really get to understand the qualities of the object because they are protected behind a thick kind of greenish glass. And this is the way it should be, I guess, for preservation reasons. In cases like this, I believe that probably exploring the possibility of looking at the original, so being in front of the original in the museum, but then having access at the same time, maybe to a small detailed reproduction that you can touch while you are looking at the original. Maybe you can have access to a small fragment of a facsimile to understand the surface, to understand the complex quality of the colors, to understand the materials, or maybe even just having access to a small monitor that you can actually zoom in and zoom out and navigate through the information that was captured digitally as a way to complete the experience of looking the original. I believe that there is a lot of room of exploration in this area, how to complete the experience of looking at an original thanks to having extra information through facsimiles. So I will go to the last tomb for today, a tomb for a cardinal, and this is one of the most recent projects that we have done. And it's about, you will see in a minute what's the complexity of a project like this, but it's also about death and resurrection through digital technologies. The Sepulchre of Cardinal Tavera, it's an important sculpture by Alonso de Berruguete, which is the great Renaissance sculptor in Spain. And there is a video for that as well. Can you see it now?
Yes.
So this is our colleague Pedro operating a white light scanner, specifically the CDO scanner. Then you can see here the faro for the space. So the CDO was being focused on the actual sepulchre. This is this massive marble element in the middle of the church, in the middle of this this building. And then with the faro, we could record the space, obtaining information like this. Remember, this is a point cloud, locating points in space, also with some color information as a reference. But the goal here was to apply photogrammetry to documenting the sepulchre in its shape and surface detail. This building is the Hospital de Tavera in Toledo. And the sepulchre of the Cardinal Tavera is something that was actually damaged in different areas in the Spanish Civil War. And this is something you could see in the 3D model that we obtained. And I will explain why this is important. So this sepulchre was recorded because we recently inaugurated an exhibition in the UK in a place called Bishop Auckland that is called a Spanish gallery. It's a permanent museum. It's a permanent installation about Spanish art, and it's probably the only museum dedicated only to Spanish art in the United Kingdom. We developed a complete narrative, an exhibition of Spanish art from the Middle Ages to the Baroque, with a selection of key art pieces from sculpture, painting, decorative arts, etc. And one of the central pieces of this exhibition was the sepulchre of the Cardinal Tavera. In this exhibition, in the Spanish Gallery in Bishop Auckland, there are no original objects. It is a selection of elements that have been recreated as facsimiles. So that the first and most difficult challenge was how to record this central piece, one of the best examples of Renaissance sculpture in Spain, how to record it accurately, how to reproduce it physically as a facsimile, with the real size, with the proper depiction of the material, and with all the complexity. And how to recreate other elements that are helping to explain the importance and the history of this artwork, and also of the character of the Cardinal Tavera and its importance in Toledo. We recorded the sepulchre with this combination of white light scanning and photogrammetry. For some areas, it was necessary to actually use one system or the other, depending on how many features you could find on the surface. So for photogrammetry, as we will see tomorrow, it is difficult to obtain proper information when you are trying to record something that has no variation in color. When you are trying to focus on a surface that is mostly monochrome, let's say mostly white, the software finds hard to locate common points between the pictures in order to recreate the volume. On the contrary, with the white light scanner, because it is basically projecting this pattern of parallel lines on top of the surface, it is not affected by the color of the object. It can work well on a white marble like this one. It can work well on many different types of materials. So at the end, it's always trying to look for what's the best system for each object. Is the object what is actually leading the decisions that are taken in terms of technology? This is the 3D model after aligning, and this is showing certain details in which you can see the parts of the figure that were damaged during the Spanish Civil War. So the Hospital de Tavera was actually taken by the different factions in the war, and they were damaging different elements inside the church. And this is one of the things that were affected, also through specific episodes during the war itself. But there is this museum in Spain that it's called Museo Nacional de Escultura, which has in storage a very interesting collection of plaster casts. It is an archive of the different plaster casts that were taken of some of the main monuments in Spain, including this sepulchre by Alonso Berruguete. And it is showing elements of the artwork before they were damaged during the Civil War, before the 1930s. So what we did is similar to the previous project of the tomb of Seti I. We had the opportunity of recording these fragments that are apart from the original element, that they could be located in a storage like this one, and then record with a 3D scanner these plaster casts that are showing the figures, how they were before they were damaged. So for the facsimile production, we started to looking at ways to rematerialize all this information. And this is where the hierarchy of importance in the elements come at play, because for the different elements in the sarcophagus, we decided to use specific techniques for reproduction. Most of the parts of the sides of the sepulchre, for example, that were mostly these flat elements, they were routed with a CNC milling machine. So as a result, they are not the highest possible resolution. But the faces of the figures, this gray color, they were 3D printed. They were actually 3D printed in-house in order to make sure that they were reproduced with the highest resolution that it's possible from the data that was captured. So you can see here that the combination of different techniques and material, also subtractive technology and additive technology, they can form the same object. Even more in this image, where you can see the full side of the sepulchre with this light orange material as the medium density resin panel that was routed, then with the gray heads that were also 3D printed in-house in high resolution, and then the corners representing these figures of eagles, they were 3D printed outside Factum in this company called Materialize in Belgium in high resolution, but as you can see, with higher scale, with higher size. So we can be composing a combination of all these different materials and technique in order to create like a complete first prototype of the object. This will never be the final material. This will not be the final facsimile. This is something that we use to make a mold out of it and then cast it in a final material that resembles, that restitutes the actual marble. It's a kind of marble composite that end up looking like marble. It's important to look also at the face of the cardinal itself. So the Cardinal Tavera, he didn't want to be portraited during his lifetime. So there are no portraits of him by any painter or sculptor while he was alive. The way that this sepulchre was made, it was made after funerary mask, a death mask that was actually made in plaster after a mold taken directly on the face just after he died. It was not uncommon at the time to actually do a face mask, death mask of the dead as a way of keeping a portrait of the person. But in this case, it was the only way that the sculptor Berruguete had to know what was the cardinal like. In the Hospital de Tavera in Toledo, the death mask is preserved, is part of the exhibition that you can see. And it was also recorded with photogrammetry. Here you can see the actual original death mask on top of a rotary table to facilitate the recording process. So you can keep the camera at different heights while you turn around the object so that you can record it from different angles in a very efficient way. And then the usual process of making a silicone mold and then casting, etc. Then, following one object to the other, this portrait of the cardinal made by El Greco, it was also made after the cardinal died, and it was made taking the death mask as a model. And this is why they are so similar in the terms of the shape and the expression, etc. In this case, because it was a painting, it was an oil on canvas, we were using the Lucida 3D scanner for capturing the surface, as well as panoramic photography for the color. And then we could make also a reproduction of this painting, making a restitution of the texture of the canvas and also of the actual brush strokes of El Greco. This painting was also damaged during the Civil War, and it was actually the actual head of the painting was cut out with a knife, and these scars, these marks, are still visible in the original, and this is what is also visible in the facsimile that we made. So all these objects that we were recreating, this was the work that we were doing in the last year or so, they were part of this same exhibition of the Spanish Gallery in Bishop Auckland, and it was all about how technology can help bring back to life objects like this one. So it is this reflection about death and resurrection that is in a way linking all the different elements in the exhibition, and is related to our subject of technology, because it's like, how can digital recording give a new life to original objects apart from themselves. Another portrait of the cardinal was, in this case, painted on a slab of stone. This is a very curious piece because it's painted actually on marble, as if it was a kind of sketch made by a sculptor. Not clear why or when, but it's like another depiction of this portrait again. So through technology, we could bring this again, give it a second life through this method of making a facsimile. And then finally, other elements that are part of this very special building in Toledo. Some of these objects are, for instance, one of the very few sculptures that could be attributed to El Greco, which is, as you know, mainly known by being painter, but also this specific sculpture of a risen Christ inside this golden tabernacle was also present there in Toledo, and we carried out this reconstruction for the exhibition. This little figure was captured with photogrammetry, but for the reproduction, which was done through 3D printing, it was necessary to apply polychromy by hand. So these images are used as a reference for our painter in Factum to take as a model and apply polychromy just by hand. As well as the gilding, the application of gold to this tabernacle was also applied by hand. This particular object, it's also in a way similar to the tomb of Raphael. It cannot be considered a facsimile representation. It's more like a interpretation, also because the top part is not present anymore. It's an element that was lost, and only some very few references exist. So we wanted to propose this hypothesis about how the top part could have been originally. And this is some close-ups of the sculpture by El Greco of the risen Christ after the reproduction that we made. The way this object worked, actually, it's believed to have worked like this. so that in certain ceremonies, in certain events, religious events, the Christ could be risen literally from the bottom of this tabernacle to the top part. And this is why we wanted to recreate also the top in order to show how it was working originally. And finally, we also traveled to Seville to look at other important elements that talk about death and about how fragile is life. So these two Vanitas paintings by the important painter Valdés Leal were also recorded and reproduced for the exhibition, in this case using the Lucida scanner, because we are talking about 2.5 dimensions, if you want, and having the possibility of looking at these paintings at close distance, because in its original location in the Hospital de la Caridad in Sevilla, they are hanging above 3 or 4 meters on the wall. So it is the first time that people could actually look at the details of this Vanitas painting with these very dramatic elements from a very close distance, which is even more shocking when you have the opportunity of looking at them like this. To conclude, because there's no more time, it is important to mention that it was not just about fine arts that we were recreating in this exhibition. We were also spent a lot of time and put a lot of research into how to document this important series of tiles from the first quarter of 16th century that are in the Casa de Pilatos in Sevilla, in order to make reproductions that could be part of this itinerary exhibition, so that not only recreating the relief and the color, but also the character, the glossiness, the sheen of the glazed ceramics, it was important to recreate the atmosphere of 16th century Spain, or the Golden Age, Spanish Golden Age. These are details of the recreation of these tiles that we could make based on the different 3D and color recordings that we made. And this is the way this specific room is looking in this exhibition in Bishop Auckland. It's the recreation of specific designs of tiles, as well as an interpretation of the typical, one of the classic mudéjar wooden ceilings in Spanish Middle Ages and Renaissance. I think we can leave it here. And thank you again, everyone, for attending. And if you have any question, I will be happy to answer.
Thank you. It has been really fascinating this time, maybe even more than usual. There is Maria that would like to ask you a question connected with the golden tabernaculus we just seen. I think I have to activate audio. Maybe I did. Not sure.
Yes, I wanted to ask if the polychromy that you recorded was the original one of the Christ.
That's a good question. So that figure has been restored recently.
Yeah, it looked very fresh.
In the Museo del Prado, this specific sculpture by El Greco, but also the figure itself also at the beginning of 20th century, it was found broken in pieces. So it had to be recomposed, the arms, the legs, the different parts of the body together. So I would say there is, in my opinion, I'm sure there is a great deal of restoration in the polychromy as well. Because I've seen old pictures in which the actual sculpture looks really broken into pieces. So I'm sure that there are gaps that had to be filled, and to my knowledge, I would say it has been very much retouched, the color.
Thank you.
We still have a couple of minutes if someone else has other questions in Italian or in English or in Spanish. You can type or ask to speak. It's really interesting also to understand how you are organized, the different parts, the more technological, the digitization itself, the art and craft part. How is so you're a team of a lot of people, and each person has usually knowledge or of all the other steps of the process. How does it work?
So the team is very diverse, and as you can imagine, we have experts for each single part of the work that we do. It's very common that normally not like one person is not just dedicated to only one task. You have to learn to adapt and learn more than one type of job if you want to, be able to give answers to complex projects like this one. I especially find interesting when there are conversations and collaborations between the digital teams and the physical and the let's say the part of the team dedicated to crafts, because in many cases you have to decide, okay, is this better to maybe fix this part digitally or physically? It will be better to leave this solution for workshop, or it's better to dedicate a bit more time in the digital part in order to prototype it already well done. So there are decisions to be taken constantly, and there's no only one way of doing things. The key is that each person in the team is ready to be out of their comfort zone and be able to try to understand what are the difficulties that other members in the team are having in order to get to the best result.
Thank you. And maybe this time you didn't speak much about the historical research itself, but it's clear from what you're explaining that it's solid. A lot of work also in that field.
Yes, we have great experts, also art historians, and we have conservators. You saw today in the projects that I was sharing with you a lot of examples of digital restoration. I will talk more about this concept of digital restoration in the next sessions, but it requires a lot of historical knowledge, but also knowledge that comes out of inspecting the material itself, not just what you can find in usual sources, historical sources, but also the spending time looking at the material characteristics of the object. It can tell you clues and valid information if you want to propose different hypotheses for restoration. But yes, absolutely, every time we propose a hypothesis of, let's say, for example, what are the original colors, what is this, how could this fragment be completed, etc., we require proper historical research in order to be able to propose something meaningful.
Thank you. I don't see any new questions. So if for you it's okay, I would say goodbye and see you tomorrow.
Very well. Thank you very much. See you
Tomorrow
tomorrow.
there will be the laboratory, so
Perfect.
more practical.
Thank you, everyone.
Thank you.